we have planned to do all these things today. We don't know whether it will be possible or not. Geometrical optics. Two main topics are there. One is reflection of light and the other one is refraction of light. Refraction will start after finishing reflection. Reflection of light, reflection may be on rough surface, reflection may be on plane surface, reflection on spherical surface. On spherical surface means it may be on convex surface, concave surface, where to discuss about reflection on convex and concave surface, you need sign convention, which will help you to get mirror problem, and then respective mirror problem can be solved by knowing the mirror equation. Okay, so let us start step by step. Reflection of light. Some of the concepts here is done by you earlier. Like if I tell you, when light interacts with a surface, light travels in the form of ray, I am wrong. It never travels in the form of ray. Ray optics we are doing as the limiting case of wave optics. Wave optics, where we assume that light like wave, it will be electromagnetic wave, travel where two field vectors are responsible for propagation of light. One is electric field vector, the other one is magnetic field vector. But I am not entering into that discussion now. Our aim is to assume that limiting case only, where light will travel in the form of ray. Okay, those rays, parallel rays, you have taken many parallel rays, say, then one parallel ray, two parallel rays, three parallel rays, they will form a beam of light. So light beam consists of many rays. So what is ray optics? We will remember ray optics is the limiting case of wave optics. Actually, light travels in the form of wave. That also I am not telling you, because just 3 days before his death, Einstein himself told, I have done 50 years of research work on light, but still I don't know what is light. Because in Einstein's time, quantum theory was developed. There was Newton's corpuscular theory 300 or 350 years before Einstein. Corpuscular theory is what? Light in the form of corpuscles, when strikes retina in our eyes, produces sensation of view. We can see object when light corpuscle strikes retina of our eyes. It is Newton's corpuscular theory. Then came Huygens theory. Huygens theory was not accepted by scientists. It came around 1678. It was not being accepted by scientists because of its complex study. Okay, light in the form of wave travel is not, scientists are not ready to accept the concept. Then came that electromagnetic wave theory. Wave theory was modified by Maxwell. This scientist merged, he was able to combine two fields of study, electricity and magnetism. He said that just two different sides of coin. Electricity and magnetism, one can act as a source of the other. This was his main contribution. They're not different. Before Maxwell, people used to think electricity one topic, magnetism another topic. With the electromagnetic wave theory, Huygens wave theory was restated, and it was able to explain many phenomena over there. Phenomena like diffraction. Regarding light, I tell you some important phenomena related to light. What are those phenomena? Reflection, refraction, that you have studied. Light, when incident on a polished surface, get reflected. On diffused surface also it get reflected, but law of reflection may not be obeyed over there on diffused surface. Then light gets scattered. Scattering of light is also possible. Okay? Scattering of light will explain the blue of the sky. That we will study here only in the optics. Light may be diffracted. When light passes through the sharp edge of an obstacle or passes through a narrow slit, then light bends through the sharp corner of the obstacle or through the hole, through the narrow slit it is passing through. So that we have referred as diffraction. There is interference also. Light waves can interfere. By interfering, a light wave can produce maxima and minima on a medium. On the screen also it is possible. Interference pattern you can see. Light can be polarized. Polarized means that we can compel light wave to pass in such a manner that electric field vector directed in a particular direction. That is possible for light. So many phenomena are there. Einstein, before his death, was not able to decide whether it is wave, electromagnetic wave, or it is particle. Quantum theory is also developed. Quantum theory says that light can interact with material particle. Quantum behavior it shows. So what about light? Is there any ultimate theory of light? No ultimate theory. With Huygens wave theory or advanced electromagnetic wave theory, you can explain phenomena like interference, diffraction, all these things. That reflection also can be explained with the help of Huygens wave theory, but Huygens wave theory will fail to explain photoelectric effect. Cannot explain photoelectric effect. Huygens wave theory cannot explain how electron can interact with electromagnetic wave, that is light. You cannot explain. So because of these two fallacies, quantum theory was developed. And that was started by Einstein only. But with quantum theory, explanation of diffraction of light or interference is not easy. I mean, almost it is impossible to explain. So these two main theories about light, wave theory, quantum theory. Sometimes light, we observe that behaving like wave to explain interference, diffraction. Sometimes it behaves like material particle interaction with material particle like electron. Its path get diverged. I mean deviated. One direction it was going, after interacting with electron, its direction changed. But direction change happened in what case? Material particle. But it is very surprising to see that the change is observed in case of light wave also. That is Compton effect. Compton effect is there. And photoelectric effect. when light incident on the surface of alkali metal, then photoelectrons are emitted. Can't be explained with the help of wave theory, all these things. So what is light? We learn both. In class 12 only you have the scope to learn ray optics, which is limiting case of wave optics, and they constitute 18 marks in your board paper. It was 14, now it is increased, 18 marks, and this is the easiest topic in class 12 physics. If you have very good sense of drawing ray diagram, then you are master of ray optics. Okay? And in quantum theory, in photoelectric effect explanation, we will study Einstein's explanation. There we will introduce quantum theory to explain behavior of light. And you know, interaction of, by observing these two in 1924, 100 years back, de Broglie, French mathematician, physicist, he suggested dual nature of radiation. Dual nature of radiation given by him, de Broglie, theoretical study. It was proved by derivation in Germany in lab that de Broglie was correct. Light has dual nature, material body, like material particle and wave. This was proved by them in lab, derivation in Germany. Historic experiment. Okay, all these you learn one by one. Today let us know ray optics. What is ray optics? Ray optics, where light travel in the form of ray. Okay, this ray, beam of rays are there. When there is a plane surface and light is incident, it get reflected, and based on this there will be laws of reflection. Light incident here, it get reflected. This is normal, drawn at the point of incidence. This is incident ray, this is reflected ray, this one angle of incidence, this is angle of reflection, and this one is the normal, drawn at the point of incidence. Then what is first law? Throughout the ray optics, whether it is incident on curved surface or plane surface, we will be using these two laws. The first law. What is the first law? Incident ray, the reflected ray, and the normal drawn at the point of incidence lie in the same plane. This is first law, and the second law is that I equal to R. The angle of incidence equal to angle of reflection. These are two laws. Wherever light incident, that I am telling you again, curved surface, that spherical surface, if light reflected, light can be reflected or it may be absorbed. We are assuming that light is reflected. A small part is absorbed. Part of it may be refracted also. Together all these phenomena can happen, but if there is reflection, then I should be equal to R. And this will help us to get the image of an object. Object may be real, object may be virtual. In ray optics, two kinds of objects are there. real object and virtual object. Okay? Concept of real object you have already. Object real, that's why light is being reflected. Image may be virtual. Let us see the case of reflection on plane mirror. Reflection on the plane surface or plane mirror. See how the concept of real object and virtual image arise. We draw this one, the plane surface. Object is here. Question is, how can you see the object? Because object is the source of light. If we get an object which is emitting light, that only we can see. Okay? So if there is an object and my eye is situated here, then the eye will be able to see the object if light from the object get reflected and reaches my eye. My eye is there. Okay? This is object. Light ray, it get reflected, and you can draw normal also there. Normal will help you. Normal, this is object, this is eye, this is the point of incidence. NP is the normal. Normal will help to understand how I equal to R is obeyed always. Okay? So this is real object. Our eye is there. I will be seeing this object. No, I cannot see the object. I is seeing the reflected one. No, he is not pointing towards that. He is pointing it. The eye is pointing towards this. Where reflected ray is going to the eye. That you can get by producing this one in backward direction. I have produced this in backward direction. This is not solid line. Okay? Now from here, if you draw a perpendicular, that light is not penetrating. It will go this way, it will come back this way. If you produce it, then you get the position of image. So this object is real one and this image is virtual. Okay? So virtual image, and there is eye. I will be seeing this one only. Okay? I will be seeing this virtual image. And in case of plane mirror, we can prove this easily, that this distance, this one must be equal to this one. I draw perpendicular M over there. If this is I, this is R, and this angle 90 degree, then this is 90 minus R, this is 90 minus R, this is R. And this thing is I. As I equal to R, so this will imply triangle OMN is congruent with triangle IMN. Okay? So if they are congruent and MN, this angle 90 degree for both, so this will imply that OM equal to MI. So it is proved that image distance is equal to object distance. Clear? So in case of plane mirror, it is proved that Distance of object equal to distance of image. And some interesting phenomenon you have seen that in case of class 8, 9 physics classes, that P, if you keep this manner, the image how it appear, I is there, its image will not change. All these I am not going to discuss in class 12 class, but I remind you the basic concept, it is required. Okay, and many interesting fact, if you remember this, we can establish. First thing we have done this, image distance equal to object distance. Now I am giving you example of the case where virtual image, real object, virtual image is there. Is it possible to get virtual object and real image? Virtual object and real image, is it possible? Is this the only case? Image always should be virtual one? No. Object also may be virtual. How object may be virtual, that we can understand, but before doing that, let us do one experiment here. Based on this, we learn one very important thing, that by keeping the incident ray fixed, if we rotate the mirror by an angle alpha, then reflected ray will rotate by an angle 2 alpha. So let us solve this problem. You all try. So let us do one problem. Problem 1. Keeping the incident ray fixed, if the mirror is rotated by an angle theta, prove that the reflected ray rotates by 2 theta. Keeping the incident ray fixed, if the mirror is rotated by an angle theta, prove that the reflected ray rotates by an angle 2 theta. We have to prove this. This is mirror M1, M2. The incident ray is there, and reflected ray. This is the normal. Point of incidence O, normal, incident ray, reflected ray, I, R. Let me explain the problem. You can solve it yourselves. I'll give you 1 minute time for that. But let me explain what is happening there. The mirror we are going to rotate. Mirror will be rotated. Mirror is this position now, and we have kept the incident ray fixed. This is mirror's position now, M1 dashed, M2 dashed. Your problem is to prove that if we have rotated, if this angle is equal to theta, this one, then obviously if we have taken the incident ray as AO, then normal is rotated. You should agree. if we rotate mirror by theta, normal run to it also rotate by theta. That is obvious. So this is new normal O in dash, and this angle of rotation is theta. Am I clear? Being a class 12 student, you understand? If I rotate the mirror by theta, normal to it also get rotated by an angle theta. That is obvious. So in this diagram, angle in O in dash is equal to theta. That is true. Clear? But you are going to prove that the reflected ray, initially reflected ray was OB, but now reflected ray will be OB dashed. OB dashed is the reflected ray, and required to prove angle BOB dashed is equal to 2 theta. Clear? We are going to prove that this angle will be equal to 2 theta. Required to prove RTP BOB dashed. You all try. I will explain then. It's very easy to prove. BOB dashed equal to 2 theta is not very difficult to prove here. Let me try. Hope all of you have done it. Just check with my calculation. Normal rotated by an angle theta. So for M1 dashed, M2 dashed, this position of the mirror, ON dashed is the normal. So angle of incidence is what? This you can write. Because normal rotates by an angle theta, so it becomes I plus theta. Therefore, angle of reflection is what? Must be I plus theta, because law of reflection valid everywhere, for plane mirror, curved mirror, wherever you take. So angle of reflection also I plus theta. But in figure, in this diagram, angle of reflection is in dashed, OB dashed, isn't it? In dashed, OB dashed. How can I get that? In dashed, OB dashed. Initially you can see that this R is equal to I, this R is equal to I. Now you want to find n dash OB dash, this one. So angle of reflection will not remain I, it is obvious. This one theta, this angle is also theta. Normal to this surface is ON dashed, ON dashed. So this total angle is 90 degree. This angle is 90 degree. Am I clear? This total angle 90 degree. So this part going to be what? 90 minus theta. Am I correct? N dashed OM2 is going to be 90 minus theta. Now from there let us find in just a minute. This is 2 theta, this is R. No, this 2 theta we have to prove. This is confusing me. So let me remove this. Yeah. So let us say the value of n dashed OB dashed. N dashed OB dashed, we have said that I plus theta. N dashed OB dashed. Our problem is to find B dashed OB dashed. B dashed OB dashed is equal to n dashed OB dashed minus n dashed OB. This is the simplest approach. N dashed OB dashed we have proved, that is I plus theta. N dashed OB dashed, this thing, n dashed OB, this is going to be, because this part is I, total was I, this part is theta, total was I, so remaining this part will be what? This is the best approach, I minus theta. So this is going to be I plus theta, I minus theta. This is equal to 2 theta. Check once. This is the easiest one. You need not consider separately the diagram, just in the same diagram only, because the angle of reflection, this I means this total will be I, isn't it? And it is rotated by an angle theta. This thing rotated by an angle theta, this total is I. So this remaining part will be what? I minus theta. So it is going to be I plus theta minus I minus theta 2 theta. So B O B dashed or B dashed O B, whatever you say, that is equal to 2 theta. But OB is what? Old reflected ray. OB dashed is what? New reflected ray. So it will give us the angle between them. Now it is 2 theta. Another question here. It's a very interesting one and very useful. That regarding, okay, that let me show you. I started with that problem, that virtual object but real image, in which case it is possible. Virtual object and real image. This situation arises many times in ray optics, in spherical mirrors, lenses. Virtual object and real image, where you use combination, it happens. But here, just by using one plane mirror, we can get quickly. This is a plane mirror, taking this way. Now there be an incident ray coming this manner, another incident ray coming this manner. Okay, when they get reflected, they are getting reflected. We'll go this way. This incident ray will be reflected this way. it will be reflected this way also. This is one ray incident at this point O1, reflected along B. This one another one. Say this is A dashed, reflected at O2 and going this manner. Okay. O2 B dashed. So what is happening? These two rays will meet our eye if the eye is kept here. If we keep our eye here, then we'll be able to see this, no? This thing we'll be able to see by using our eye. Eye is there, say, we can see the image of an object. Okay, eye is placed here. I can see the image. But where is the object? Rays are coming this manner. Objects are in indefinite position. No, object is not at indefinite position. Object is there. How to get it? For that, we will be producing this in forward direction. Okay? This also in forward direction. They will be meeting at a point. This is dot dot. This is object virtual. Its image is formed here. This image is real. Okay. This object is virtual and this is real. Clear? So image real but object is virtual. Where they meet, that is position of image. Many things can be proved, but we cannot do all here. You get the concept and start practicing problems on it. Now I am going to show you one very important thing. It's a practical problem. You are standing at the middle of room. In the front wall, what will be the length of mirror so that you can see your image fully? Okay, this is the problem here. Find the minimum length of a mirror which will help you to see the full image of you. Find the minimum length of a mirror which will help you or me to see the full image of you or me. Okay? We can prove that if the height of the person is h, then the length of mirror h by 2. This is height of man and h by 2 will be height of mirror. We have to go by ray diagram only. What ray diagram? You have to get it by ray diagram only. See how to get it. Mirror you take. I am taking mirror here. Oh, not so big. Your position you take first. Here. This is you standing here. You are standing on the ground. Ground is there. standing on the ground here. So your feet, your eyes and your head, these three very important. Your feet, let us take this one as F. Man's head you take, okay, we have to take different. F you don't take, you take this one as AB. AB is the man and his eye is there. Okay? Eye is there. You are keeping a mirror in front of it. Okay? Wherever you keep, the most important condition is that this is the mirror, huh? This is ground, this is not mirror, ground, but this one is mirror. So I will be naming this one as M1, M2. This mirror I am naming as M1, M2 to avoid confusion. Okay? So what will happen there? If a ray of light from the head, this is position of your head, your eye and your feet. So if I send a ray of light it should reach at the eye, then only you can see it. You agree or not? How can I see? How can I see or you see the image of your head? Your head you have to see. Your whole body part has to be seen with the help of mirror. So every body part's image will come to my eye. So suppose it is going this way, incident here. The reflected ray must come to my eye. Am I correct? This ray coming from head, meeting at the extreme edge, and then it will reach my eye. What about this? From feet also it has to go. One day going there at the extreme end, and then it's going there. Okay? So the man will be able to see the full image of his own. Am I clear? He can see the full image of his own. You have to find length of M1, M2 in terms of the height of the man. Okay? Problem is clear? Now let me prove that. See, I am proving how I am proving it. Taking this one. Just to prove it, you draw a perpendicular here. No, this is not very clear. So I have to change the ink. I am taking this one. From M2, you draw a perpendicular. M2L. From M1 also, you draw a perpendicular. Okay? M1S. These are two perpendiculars I have drawn, but mirror and your position is clear. Your eye is also clear. Now, you know, this angle equal to this angle, so definitely this thing going to be equal to this thing. Agree or not? Again, this angle is equal to this angle, so this thing going to be equal to this thing. Agree or not? Am I clear? So if I have taken this one as x, this will be x. If I have taken this one y, this is going to be y. Quite obvious. You are a class 12 student. I need not explain more. From M1 I have dropped perpendicular, from M2 also. So these two angles are there, A, M1S, and then these two are congruent triangle. Why? Because 90 degree is there, common thing is there, and this is equal to this thing. If you say this one alpha, this has to be beta. If you say this one beta, this has to be beta. Clear? Understand? So this part y, this part y. Now in terms of x and y, what is your height? It matters. Your height is going to be what? Your height h, that is going to be x plus x, y plus y. So h equal to 2 into x plus y. Length of the mirror. Length of the mirror quite obvious. Everyone will say x plus y. Mirror length x plus y. So x plus y is half of h by 2. So if your height is 6 feet, you need a 3 feet mirror to see the whole person of you. Clear? Understood? Now take one homework based on this. Just write. A person is standing exactly at midway between a wall and a mirror. Okay? Show that minimum length of mirror or height of the mirror, in this case should be h by 3, where h is the height of the man. Okay? So this is the wall, this is mirror. I explain the sum, you will try at home. Okay? So this is wall. Wall is W1, W2. You are standing here. You are standing here. How do I dare to write this manner? I have to see the full image of myself. Where? Not in the mirror, in the opposite wall. Okay? Then height of this man, height of the man, I am taking this one as AB. AB is the man. Standing exactly midway between these two. This one say A, this distance, so this distance has to be A. Clear? Now how the image of the man will go to the wall, you will decide, and you need to prove, required to prove, the height of the man is h RTP M1 M2 should be h by 3. You will try at home. Not a difficult one. Just use the concept you have learned. Alright. So how can you do that? You send a ray from wall. This is man's eye. Man's eye. man's eye you take anywhere, it doesn't matter, because here this side and this side is related. So only problem is that this light should go to my eye over there. Clear? Kotte gelo? Where do you find this? This is coming from one extremity of the world, it's reaching our eye. Similar is the case from the other extremity. Light incident here, goes this manner. Okay, now your problem, just by similarity in class 10 geometry, to prove that M1 M2 going to be equal to h by 3. Clear? You will try at home. Oh sorry, this h is not height of the man, this is h is the height of the wall. Sorry, I forgot to write. Height of the wall, not the height of the man. Okay, try. All the best. Now many questions I'll share with you on this topic. Right now I am just going to tell you what is angle of deviation. What is angle of deviation? And I'll give you one example on it. Just write. Angle of deviation is what? That I have not defined yet. What is angle of deviation? Tell. You write the angle of deviation in terms of I. Can you write? You can see the deviation angle easily. Just taking a problem this manner. Light coming this way, normal going this way, and then reflected so that it become parallel to first one. Okay, this is first mirror, this is second mirror. Angle is 90 degree. Your problem is to find, wait a minute, 90 degree, no. Achha, you prove this thing. To prove that for any, this is 90 degree fixed. Whatever may be the direction of incident ray, reflected ray is parallel to it. Just prove it. Prove that for any value of angle of incidence, I, these two rays are parallel. Try once. This incident ray and final reflected ray, these two things are parallel. You have to prove it. It's easy to prove. This angle 90 degree given, so this part will be, this is reflected ray, so this is also I, 90 minus I, this part I, 90 minus I, 90 minus I. Clear? To prove that what? AL is parallel to A dash M. To prove AL is parallel to A dash M. This we proved. It's a class 8-9 level geometry. If sum of two interior angles when a transversal is there, if you can prove that this angle plus this angle equal to 180, then these two must be parallel. So here by assuming this one I am getting this one 90 minus I, this is 90 minus I. So the proof is done in one step only. As angle ALM plus LM A dashed equal to 2I 90 minus I, so 180 degree. So right, at sum of two interior angles 180 degree, so AL must be parallel to A dashed M. Understood? Now let us go for spherical mirrors and do problems solving as many as possible from the books you normally follow. Verma, Irodov, Resnick Halliday. Your textbook NCERT must. I don't know how many sums are there in reflection, but that you must do always. Now let us see reflection at plane mirror. Reflection at curved mirror. Reflection on curved mirrors. Achha, one thing I'd like to say, objects are real and virtual, I told you, no? Objects said to be real, at least two rays are coming out of it or two rays are meeting it exactly. Then objects we can say that real. Objects are said to be virtual, then two rays supposed to meet it but not, appear to meet but they do not meet actually. So understand difference between real object and virtual object. For real object at least two light rays will meet or come out. For virtual object appear to meet, they do not meet really. That is virtual, appear to meet. Plays very important role in case of curved mirrors. Curved mirror means these are called spherical mirrors. What are spherical mirrors? Glass sphere is there. Glass sphere made of glass is there. From there, you take a small part. And silver it. I am taking this small part, silvering this side. Then I got a mirror. Aperture of the mirror going to be AB. Okay. This mirror will behave like concave mirror. This portion then AB, this will behave like concave mirror. It has a center of curvature which is nothing but center of the sphere of which it forms a part. This is spherical mirror. Alright. This is spherical. What kind of mirror? Let us take it out. If we have a mirror like this, concave towards the rear medium, no need to say, just one part silvered, quite obvious. So there is a center of curvature. This is called pole. This midway is called pole. Pole is there. This is center of curvature. If you join these two, you will be getting principal axis. Okay. This spherical mirror will be referring as concave mirror. concave mirror, because this is not exposed. When you have silvered, this is not exposed. The part which is exposed here, which part is exposed? The curved part, this part. That's why it is concave, concave towards the medium. On the other hand, if you have taken a slice, I mean a small part of it, don't say slice, it is wrong statement over there, and silver this portion, then this mirror CD is called concave mirror. It is also part of a spherical mirror. So this one is a convex mirror, not concave, convex. This one is a convex mirror, AB. Okay? And this is also part of this sphere, so center of curvature is well defined. There is a pole midway between these two. If we join them, then you get the principal axis. Okay? If you join the center of curvature and the pole, then this is called principal axis. Now question for you. If you send a ray on the convex surface or on the concave surface, what path does it follow? Which rule will be valid for that? That is very important to understand. You understand what I said? If you send a ray, how does it move? If you send a ray, how does it move? That is quite obvious. If we send a ray, we have to keep in our mind that it is going to follow the law of reflection. No refraction here. So suppose I am taking a mirror here like this. This is going to be a concave mirror. This one is a concave mirror, AB. This is a concave mirror. I have taken aperture very large. Never take aperture very large. It's very confusing. If I send a ray any direction, I have no specified direction, sending a ray this manner. Okay? Then it will follow the angle of incidence equal to angle of reflection. But how will you draw normal here? A very common sense. A part of sphere. If we draw normal at a point, then it has to go through the center of curvature of the sphere, of which forms a part. So this is our normal. Point of incidence is there, and this is the normal. You take this point as P, and this is N. Pn is the normal. Here it will obey the law of reflection. It has to go this manner. Okay? So going this way, coming back this way. This I should be equal to this I equal to R. Angle of reflection obeyed over there. You can do few more experiment. Just let us see how did it pass if we send it parallel. If we send it parallel for a spherical mirror only, parallel to the principal axis, where does it pass through? Mirror, principal axis, ray of light made to pass parallel to this. Again the same concept. Normal you have to draw, otherwise you won't get anything. Normal, if you don't draw, then you are confused. Imagine a normal is there. Sometimes you do it by imagination. This is the normal from the point of incidence. Point of incidence is A here, AN is the normal. Then the reflected ray, it will obey the law of reflection, it will go this manner. Clear? So if a ray is sent parallel to the principal axis, this ray, then it will intersect the principal axis, that will refer as focus. Why? Why this is said to be focus? This is very important. Because if we send a beam of parallel light, they will be meeting at that point only. That is focus of a spherical mirror. Clear? So if you send a ray parallel to principal axis, it will meet at the focus. Now question arises, if we send a ray through the focus, then how does it move? If we send a ray parallel to, if we send a ray through the focus, this is focus here, we are sending a ray through the focus. We are sending a ray through the focus. How does it pass through? It will pass parallel to the principal axis, just opposite case. You send it parallel, it will pass through focus. You send it through the focus, then it will be parallel to principal axis. Why? Why it has to go this way? Because its center of curvature is never at F. It is far away from F. It is there, somewhere like this. This is center of curvature, O. Draw a normal. It will obey the law of reflection. You can easily prove that if this angle is theta, this one going to be theta. You take this one theta, this will be equal to theta. Done. So if you send to the focus, it will be parallel. Oh, sorry. Okay, this angle theta means this, you can prove this is also theta. This is theta, this is theta by law of reflection. So this is a very important observation. Now the last question in today's session, if we send a ray through the center of curvature, then what will happen? We are going to send a ray through the center of curvature. Then how does it pass? Principal axis have taken, mirror aperture also we have taken. Okay, this is center of curvature. If we send a ray through the center of curvature, this center of curvature, say we have taken O, then this is the normal direction only at this point. So if it goes this way, it has to come back this manner. So if you send a ray through the center of curvature, this is center of curvature, it has to pass through the, it has to pass undivided. It will retrace its own path. Clear? Understood? See you again next week.